to do in this video is look at how you work out the formula of a linear relationship given a description of the situation and some specific information. So if we have a look at what we've got here, Ace Taxi Services charges $3.30 for stopping to pick up a passenger, and then $1.75 per kilometre travelled thereafter. So we can see that we've got that sort of flag fare of $3.30, and then we've got a rate of $1.75 per kilometre travelled after. All right, so what the question asks us to do first of all is to complete this table. So what it's asking us is if the distance is 0, that means we're not going to have any lots of $1.75. What's the cost? Well, it's only the flag full, isn't it? So we've got $3.30. If we are going 2 kilometres, we've got our $3.30 flag full plus 2 lots of the $1.75. So that's going to give us $6.80. Now back over here, I didn't need to put the dollar sign in the body of the table. Okay, so if we've gone 4 kilometres, it's $3.30 plus 4 lots of $1.75, which is going to give us 10.3. If we've gone 6 kilometres, it's $3.30 plus 6 lots of $1.75, $13.80. 8 kilometres is going to be $3.30 plus 8 lots of $1.75, and 10 kilometres, $3.30 plus 10 lots of $1.75. Next, we're asked, what is the dependent variable? So remember when we graph things, we've got independent and dependent variables. A really simple way to remember which one is the dependent variable is just to think about which value depends on the other one. So in this case, the cost is going to depend on what distance has been travelled. So we'd say that the cost is the dependent variable and the distance is the independent variable, because the distance is what it is and then we work out the cost based on that. So something to keep in mind when you graph this information is that your dependent variable is what's going to go on the y-axis and your independent variable is what's going to go on the x-axis. Now we've been asked to graph cost against distance. Okay, so what you need to do is set up your set of axes, making sure you choose an appropriate scale and enough room to cover all your values. It's important that you also label your axes. So your y-axis is cost in dollars and the x-axis is distance in kilometres. And then we can plot our points. So at 0, it was 3.3. At 2, it was 6.8, etc., etc. And once you have plotted your points, you can then join them with a nice linear line. Keeping in mind I've got the arrow on this end because as the distance keeps getting larger, the cost is going to keep getting larger as well, and that will just continue on. In the next part, we're asked to find the rule connecting the variables. So basically, if we're talking about a rule connecting the variables, it's asking us for the expression, so the equation or the function that describes this situation. So if we think back to what we know about linear relationships, we know that y equals mx plus c. So basically that's our slope and intercept form of the equation, where m is the slope and c is the y-intercept. And we can tell from either looking at the graph or our tables of values that the y-intercept, so that's when x equals 0, in this case, is 3.3. Now, in this situation, we had a rate of $1.75 per kilometre. So our slope is actually equal to the rate. So, because if we think of what slope means, so that's our y step over our x step, so how far the graph step has gone up for each step across. So with our rate, if we go across 1 kilometre, I've actually drawn that bigger than 1 kilometre. Okay. If we go across 1 kilometre, we actually move up like that. We actually move up 1.75 or $1.75, because for every kilometre it costs $1.75. So the $1.75 per kilometre is a rate, and when we're dealing with these linear functions, that rate is related to the slope. So in this case, we've got slope is $1.75. So substituting those values into our general form here, y is going to be equal to 1.5x plus $3.30. What we need to keep in mind though is we've got a specific situation here. So we're looking at the relationship between cost and distance. So our y values are actually representing c for cost, and x is really d for distance. So we need those variables in our expression, and we're also going to write this using function notation. So instead of y, we would replace it with f of x, but in this case, our function represents cost. So we're going to go cost, and so instead of f of x, so instead of f we've got c, instead of x we've got d for distance. So we're talking about the cost per distance is equal to 1.75d plus $3.30. Lastly, we were asked to find the cost of a 9.4 kilometre trip. So really what that is asking us to find here is the cost of a 9.4 kilometre trip. So we're just substituting 9.4 in place of d. So doing the multiplication and addition there, you'll see that that's 19.75. It's really important that you put that answer back into the context of the question. So 19.75 represents $19.75. So therefore the cost is $19.75.